cannot use shielding, and that is inside of our receiver room on our telescope, which there's a poster of over to your right. You can see the red circle that shows where the receiver room is located, and over further to the right, that is the side of that receiver room. There are 8 receivers on a turret, and we spin them depending on what type of frequency level we are studying at. But if we use shielding in that room, if the man-made radio signals cannot get out, then the very faint signals from outer space cannot get in. So to ensure that the telescope remains radio quiet, we use a cryogenic system of compressed helium. Compressed helium is around 430 degrees below zero. It's only about 15 degrees warmer than absolute zero, so at that time all molecular energy slows. It is in a gaseous form. We cycle it throughout the receivers to ensure that energy is reduced and less interference is created. Now it's kind of hard to understand how that works, but it's pretty easy to demonstrate it with a balloon and some liquid nitrogen. Liquid nitrogen is about 350 degrees below zero, so a little bit warmer. It is in a liquefied state. But this balloon was probably blown up yesterday, maybe even the day before. It has a lot of air molecules inside. The air molecules, they vibrate back and forth. They have great energy, and it keeps this balloon inflated. So we are going to imagine that our balloon is the receiver on top of the telescope. As it works, the molecules vibrate back and forth. Since it is an electronic, it creates an internal noise, a static interference for our telescope. So to minimize the interference on the telescope, we would turn on our cryogenic system. And with our balloon, we'll subject it to our liquid nitrogen. And since the balloon follows the shape of our air, we'll be able to see that as the molecules become cold, they start to compress together. And that's because they're reducing in their energy.
That's too cool.
And if this were our telescope, this would be a great time to study, because molecules have compressed together. They have reduced in their molecular energy. But we see as soon as the balloon hits room temperature, the molecules, they start to regain warmth. As they regain warmth, they regain energy. They'll once again start to vibrate back and forth, rotate, and our balloon will re-inflate. So if this were our electronic, our receiver on the telescope, it would once again be creating interference. So we run that cryogenic system 24/7 to ensure the molecular energy is reduced and therefore less interference is created. I will pour out this liquid nitrogen for the sake of your video.
Oh, cool.
It will not hurt you. It will not hurt your feet. It also will not pollute our air.
Wild.
Our air is made up of about 73% nitrogen.
Whoa.
That day I was using this to make that ice cream. And it's like long day.
Okay, wait, don't video this part. Here, blow in my bucket.
Oh.
Your eyebrows will come back like in 3 days.
I'm saying. I don't need it.